Alrighty, do it. Lexicographically minimum string after removing source. Given string s, if it may contain any numbers of asterisks. Your task is to remove all the asterisk characters. While there is an asterisk, do the following operation. Delete the leftmost asterisk and the smallest non-asterisk character to its left, the smallest. If there are several smallest characters, you can delete any of them. Return the lexicographically smallest resulting string from removing all asterisk characters. So here, the smallest non-asterisk to its left. So here the asterisk is there, so you can remove any A, and it's best to remove this A in order to make AAB. If you remove one of the first two A's, it'd be ABA, which is going to be after AAB. Okay. And there's no asterisks. Okay. Seems reasonable. I think I understand it. So you can delete anything to its left. So let's say you had two asterisks and you had A as the lowest value. Let's say A, B, A, asterisk, A, asterisk. So this asterisk can only remove one of the two A's here, and this asterisk can move any of these two, any of those three. And the best thing would be for to remove this A and this A, and leave AB. If it were to remove like the first A at all, then it'd be A as your answer. That doesn't work. So what's the generalization here? Do you always want to remove the furthest one, the furthest smallest character? The furthest smallest character. I think that's correct. Would you ever want to remove an earlier smallest character? I don't think that's right. And I guess, well, you have to do it in order. Okay, delete the leftmost and the smallest okay, delete the leftmost and the smallest non-thing to its left. I wonder, I think this is just maybe a stack where I keep track of whatever the smallest is, whatever the furthest smallest is. Maybe a heap. Because all you care about is the smallest, and you're pulling from the heap at that point. What if, so if you kept track of the heap where you had on the heap the character and its index, and then anytime you see an asterisk you take off the heap, and the heap is something where you can always keep the lowest or the biggest of the elements within it. You can always pull it out in constant time. And then, so what happens at the end? At the end you would have a heap that has elements that haven't been deleted, and you would need to maybe sort the heap to figure out what you still have containing. what's the other alternative to that? Like a heap is going to have basically n log n time. Yes, it basically will need to sort at some point. What's the length of this thing? 10 to the 5th. 10 to the 5th is within n log n time. It's not, it can't be n squared. Can it be a linear solution? A linear time solution. So if I kept track of the stack, where on top of the stack, I kept the smallest elements. I don't think it can be I feel like it might not work because let's say, for instance, that you have a stack, right? And I'm thinking of a monotonic stack. And you have CBA asterisk asterisk. If you kept a track of the stack where the stack is just the kind of smallest elements up to here, it would be like C, and then C gets removed from the stack, and then it's A, and A, or B, and then B gets removed from the stack, and it's A. And then the asterisk would pull from the stack and take away the A. And then the next asterisk doesn't know what to take away. So I think this is a heap, so I'm going to try. So attempt 1. Attempt, say, use a heap to keep track of the lowest elements to not keep track actually, to always be able to get the lowest element thus far whenever an asterisk is encountered. Move from heap, move lowest from heap, and then sort heap to get remaining characters afterwards. So let's go and try this. He's going to have empty, and then for each character in the string, actually I think I need a for loop with indices for each index in range n, where n is the length of the string. I'll say the character is going to be in the s of this index, and then I'll add it to the heap. So heap dot heap. Actually, I think it should be as heap push onto the heap. This character. I think I need a tuple. So it's going to be a min heap. So A is automatically going to be smaller than B if you were to do normal heaps in Python. But because I also need to keep track of the index, I would normally do something like this. A tuple that is the character in index. But because this is actually going to sort it where the index that is smallest would be in front, I actually want to prioritize the index that is farthest down the line. So the way that you do that would be, I think, putting this to be negative, so that when it pulls it, it's minimizing a big negative number, which will be more forward. And this is only true if the character is not an asterisk. You can do this. What if the character is the first thing? The input is generated to delete. It is possible to delete all asterisk characters. Okay, so the asterisk will not come before like a character, or it's not going to be possible. So I don't need to check that there's an actual heap here. So if it is an asterisk, then I'm going to heap pop from the heap, and then afterwards I'm going to sort by the index. So array is equal to oh man, my lack of Python fluidity is going to become apparent here. I think it should be sorting by key. Array is equal to sorted of I'm going to do heap dot sort where the key is. Oh god. Sort key Python. I need to be better at this. The sort method. Key, an element of a tuple. Okay, sorted list is sorted my list key lambda x tuple x element 1. Okay. So let's say I have an array which is sorted. I think if that's first thing is the list, which is the heap, and then lambda key equals lambda x, where x is using the shucks. The first element is going to be a negative number. At this point I want it to be positive, so I think it needs to be negative of x1. So this will take the index, put the positive version of that x index, and sort based on that. And then I need to convert that array of it's now going to be array of tuples, and I need to convert that to my answer. So answer is an array. First, the fastest way is to create an array of characters and then doing a join on the character array. So I don't want to do a bunch of concatenations strings. So for each element in the array, answer.append the character in that element, and then return the join of answer into a string. Heap push. Is it not heap push? Maybe it's heap q. How do you do heaps in Python again? It's not heap push. Heap q.heap push. A heap q has no attribute heap push. Did I misspell heap push? Oh, I see. Too many p's. Okay, so it worked. Okay, so it worked. Very nice that it passed in the first go without having to do a bunch of error debugging. I feel like there should be a better way of doing this. From the list of from the heap itself. I wonder if I can just use Google with this. Okay, so AI convert a list convert an unsorted list of tuples by into a single list using an element of the tuple as the key to sorting the list. Okay, well, this is what I did, kind of. So, item, sort in place. I guess this might be better if it's just sorting in place. It's key lambda x. So I can just say heap dot sort key lambda x, where x is the first element of the tuple. Okay. Wonder if it's easier to do list comprehension for the other one. So answer equals the array for k, or say element bracket 0 for each element in the heap now. Maybe that's slightly faster. Same speed. No, they're the same speed. Okay, so is the difference between my solution versus other solutions like n log n versus log versus n time? I don't think so. I have a feeling that this is not the difference between n log n and runtime. So is there a better way of doing what I did? The character is an asterisk. Push onto the heap. Can I do this in linear time? So I go through the elements of the string. I need to keep track of the lowest elements. I need to keep track of, if I know how many characters I have, how many asterisk characters I have, then what if I only kept track of at most some number of characters onto the heap, right? Because there's no reason for me to keep track of anything more than that number of characters. So like for instance, if I had, let's do one pass. Counter for the number of asterisks. So ast count for every character in string if the character is an asterisk, and asterisk count is incorrect. Not confused with some other mispronunciation of that. So if the character is an asterisk, Uh, it's gonna be a little. So I would always need to push onto the heap, but then I would pop off the heap if the heap size is more than the asterisk count. So if the character is an asterisk push, and then at this point if the length of the heap is greater than the number of asterisks, then then heap pop. No, what am I doing? I can't pop it. No, even if I just wanted to keep track of, let's say, 5 asterisk characters, I would need to know what the 5th largest one is, or maybe what the 6th largest one is. There was a way that I learned at some point to have a heap be of a certain size, the top 10 elements of a thing. So if I were to have too many elements in the heap, oh, is it like I need to keep track of the largest of the elements? Keep track of the largest element. So every time I see an asterisk, I remove the smallest element seen so far. And it's not necessarily like if there's 5 asterisks, it's not necessarily that the 5 smallest elements of the string is pulled out. Because if it's like there's a B asterisk to start with, then the B is going to be removed regardless of whether or not B is actually the lowest character in the string. So suck dash. If I were to, I need to track the lowest one. Make the most sense to use a heap for that. But I guess the issue is like there should be some way to optimize how much you're doing. Because if there's no more asterisk in the string, right, then what's the point of using a heap at all? Like what's the point of doing anything? It's like your answer is just your answer from then on. What if at any given point I kept track of the smallest thing that is to the left of that index? Unfortunately, it doesn't quite work. Or does it not work? The smallest thing to the left of it. So for instance, the asterisk here would keep track of this A, and this asterisk here would keep track of this A. Look, there's like multiple asterisks here. And let's say CA So what happened? So I go right to left. This asterisk will stop at this one. Stop, and it will take that out. And then this asterisk, when it goes here, it's going to do what? It's going to say pull this one. What if each index keeps track of not just the lowest value, the index of the lowest value to the left of it? So for instance, if this asterisk is this thing, then it's this asterisk. When it tries to pull this thing, it'll actually pull maybe this one, because this one will point to this thing at that point. So so when this thing gets pulled, it'll look at it will have an index of the character leftwards that is smaller than it, so that if it gets pulled again, it uses that character and then replaces it again with the character that points to. Might work, maybe. Okay, so for every index in range, and for every index in the range of n minus 1 to negative 1, negative 1, going backwards. How would that even work, actually? So this index, what would it do? So for any given index, the smallest element, the index of the thing that's smallest to the left of it, then, but then what if it was like this, right? What if you actually had 4 asterisks here? So this A would remove itself and then it'd point to this A. And then the second asterisk would remove this A, and then it would point to this A. And then the next asterisk would remove the A and point to this A. And then the next asterisk would remove, well, let's say there's 5 asterisks. At that point, it would move this A, and then it would need to remove that B, which is after it. Doesn't seem great. It doesn't seem great at all. Yeah, it just doesn't seem like you'd be able to optimally have, or seems very complicated to keep track of that many things. With the element to the left of it that's smaller than it, but then if there's nothing to the left of it, then maybe the element to the farthest right of it that is slightly bigger than it, but then the asterisk could be over here, and then you have to do C rather than B. Alright, let's look at, I was going to actually look at a hint, but there's no hint. Yeah. First and final attempt. first and last attempt. Is this how I go out today? I guess it is. 62%. A lot of memory. Wow, that's a lot of memory. Compared to other decisions. We have a heap. I think you need this now. You need to load both the character and the index. If you will use a heap. I guess there probably is a way to not use a heap if this is going to be that much less memory. Alright, one final pass through. Could be a linear. Answer. Actually, I think a small optimization is if you have the asterisk count. If you have an asterisk count and your asterisk count goes down to 0, then you should stop doing all this crap. But if your asterisk count is bigger, then you should probably keep on doing it. So, for instance, if I said something where count many asterisks, and then if it is an asterisk, then I pop it, and I say asterisk count minus equals 1. And then what? And then if the asterisk count is 0, actually I should probably say if the asterisk count is 0, then just return the answer here. Return S. This is trivial. If the asterisk count is 0 here after I did this, then I should be able to break, maybe. Should be able to break. Do I want to do all this stuff here? I do need to sort the heap. Maybe it's just this thing right here. Sort the heap, answers the stuff in the heap sorted, and then answer is also everything after this index in the remaining portion of the string. So S from index on, from this index on, index plus 1 on, and then join, maybe. I don't think this syntax works actually. This seems really bad. Seems really bad. Oh my god. I'm trying. How is that not anything? Jesus. It saved me memory though. Saved me quite a bit of memory compared to other solutions. Alright, I'm gonna follow this route. Okay, just out of curiosity's sake, was there a linear solution? Heap push, that's not linear at all. Nope. Alright, I'm satisfied to say that this is an optimized or has an optimal data structure used, even if it was not necessarily the most optimal way of using the data structure. Okay. I think this was a decent attempt at some sort of improvement as well, even if it seemed to actually go slower. Alright, in summary, I guess that was summarized in the first attempt within the first 5 minutes. But basically, since the low value is needed very often, like every time you need asterisk, you want the low value, things that you see so far, use a heap data structure to keep track of the low value / index thus far in string. Note that you want prioritize or prioritize a higher index over low index when removing the low value. So an A that appears afterwards, that appears after another A, is something that you want to remove. So like this asterisk wants to remove the latest low value. So the latest A. If there's 2 asterisks, then we're moving the 2 lowest A's, right? So here, so this is heap push onto the heap, the tuple that is the character and the negative index. Since Python will auto sort based on auto compare based auto will determine the low value of heap. And you want a lower index using a negative value rather than if you want a higher index as priority, then you want to make it negative. And then so have a loop that goes through each index / character and adds to heap if normally, or if it's an asterisk, remove the low from the heap after heap is done. Loop is done. Convert heap, which is like basically an array of tuples into string by sorting based on index of tuple, and then converting letters character of tuples to an array, to an answer array of characters, and then converting that, and then make into string using join. And this is better than just adding individual characters concatenating onto a string, because then the concatenation is actually, you're making a new string each time basically. That's going to be really slow. And there was a slight optimization that didn't seem to actually work, which was like if there's no remaining asterisks, then just go to the end. Alright, time complexity, this is O of n log n, where n is equal to the length of string. Since, well, it's more like O of n log k, kind of, actually. And k is maybe the maximum size of heap, which could technically be n, but it's normally much less than that. Since insertion or pushes to the heap require actually insertions to the heap is O of 1 time removals from the heap. Actually, insertions onto the heap is log n time. Removals is constant time. Yeah, actually, insertions on the heap is since insertions into heap. Insertions, which are pushes onto the heap, require log of let's say h, not log of n, where n is the number of elements. And you do that a bunch of times, do a bunch of pushes like that. Space complexity, this can be O of n for heap.